guys give me a 5 for 5, and we will rock this out, baby. I'm gonna rock the Casbah. You know what I mean? So what is crack-a-lacking to all my peeps? Everybody doing okay in there? I think Axe was the first one in here. Yeah, what's up, Axe Nacho? I'm not sure which one's there right now. If you guys don't know who Axe and Nacho are, you need to go over and check out their channel. Awesome stuff. They're one of my favorite Canucks. I'll tell you that much. Been here since the beginning, supporting 100%. 5 for 5, huh? Okay, so we're going to go ahead and get started, guys. And, yeah, YouTube-y stuff. Got to do stuff for the YouTubes. You know what I mean? Anyway, if you're not subscribed, please subscribe. All that mess, right? Hit the notification bell. Those kinds of things. Super chats are on. If anybody wants to support that way, it's great. If not, no big deal. Okay, guys, so we do, and I was over on the lifeboat last night, guys, and we'll talk about that at the end. Did a live stream with Tommy over there last night. So I left a community post about it, and I think I mentioned it before anyway, but I'm pretty sure I did. But that did happen, and it was a lot of fun. So, okay, so we are under, I guess, quote unquote, geomagnetic storm watch. Well, we'll just go over here to Dr. Tony Phillips' page real quick. This is spaceweather.com. And a glancing blow CME. I've already talked about this CME. You know, is what it is. It could be a hit, or it could actually miss. And so let me show you the CME. Let me grab it here real quick. Okay, there it is. All right, so you got that one blowing off there. And I'm not sure if this is the one that they're speaking about, but there was also another one, but I think this other one that blew off this direction could have been going too fast. I mean, off the wrong way, I should say. Sorry, guys. I'm not sure if you guys can hear that in my voice. I'm not really feeling the greatest today. Just got some sinus things going on. I haven't had sinus stuff in a long time. But this is the end little spiral, NASA's version. This is the CME tracker. And so it's a top down on the left, side cut here in the middle, and then your orbital line stretched out in a straight line. So with that being said, I will grab this slide bar and we'll take a little bit closer look at this. So you can see this is Earth, this yellow ball. Now it is going kind of to the south. And then this one here, north-south view. I shouldn't have said south here. This was see what I mean, guys? I am not feeling good. Anyway, this is actually going to Earth's would be east. Remember, when you're looking at the sun on these models, you got to flip east-west. Okay? So if you don't do that, you're going to get your directions wrong, because you got to pretend like you're standing on the sun looking out. Okay, looking up. And they do that for, I'm not really sure the exact reason why they do that, but I'm sure everybody has to go by the same sense of direction, or scientifically, when you're trying to work out equations and things like that, things get all jacked up. You know, you don't want to have the metric form of measurement versus us over here with inches and, feet, right? So they try to keep that form of measurement the same, so basically everybody can work together and, with scientific stuff. So anyway, it does look like it could be sailing to our east, okay? But again, guys, I have to stress, there was another CME over here that actually looked like it could give us a glancing blow also. So I'm not sure exactly which one they're talking about here, because it was roughly about the same time when these things happened. And remember, the range of time that these things get here varies greatly. Okay, it could be, 1 day, or it could be 5 days. Now, if it's a 1 day thing, obviously that's coming really, really fast. And everybody would be talking about it. So, because that means it's going to be coming really, really fast, which also means that it's going to be a hard hit. So, just wanted to bring that up there to you. Now, right here, it's supposed to be on the 2nd, okay? There was one, this is NOAA's official forecast. Now, they haven't actually got it here yet, and they may not put it there because it is just a chance of this happening. And it does look like it's probably about a 50-50, maybe 60-40 chance. And if it does hit, most likely it's going to be a low-level storm. So I don't want anybody freaking out or thinking it's going to be some big, huge hit, because it's not. But we also got other things happening. We have a huge sunspot getting ready to turn in. Okay, so let's go take a look at that real quick. This is from SDO. And again, guys, I'm not going to show it to you tonight. But it is the satellite in geosynchronistic orbit. Again, it's from our point of view. Okay. And so what you're looking at here is the sun, and those blemishes on it are the sunspots. So you're looking at a black and white on the right there and the colorized version on the left. The colorized version kind of gives us a more pinpointed look here. And you're looking at polarities. So you got positive and negative. And if you see a sunspot in the southern hemisphere, it's actually going to show up the opposite of this than what's in the north. Okay, see right here, you got blue and red, and up here you got red, blue. So, just to point that out. Now, this right here, that's a big sunspot, guys. It's a large one, and it has been pretty active on the backside. So, I'm not sure if that's the same sunspot that was like hyperactive that rotated through a couple weeks ago, and it could be. It very well could be, because I mean, these things last sometimes a couple cycles around the sun. So we're going to have to keep our eye on that sunspot. Let me move in here a little bit. And we're not getting a really good look at it yet, because it is on the side. Okay, it's on the limb of the sun. Again, this would be the eastern limb. So we got kind of a decent look at this right now. Now, if that thing was to flare right now, we would still catch most of the x-rays from that. Because remember, x-rays go out in all directions. Okay? It's not like a CME that has a specific cone of plasma that can be pinpointed and more dense. X-rays are just what I just said. It's a form of light, so, and radiation, and it gets here in 8 minutes, and it goes out in all directions equally when it explodes. So, or when it erupts like that. Now, as I get going here, the black and white version does allow us to see a little bit different things here. It just gives you more of a contrast, I guess. But these two views are showing us the same thing. Okay? But this is that sunspot that's actually exiting. That was that big one that gave us the X 6.3 flare earlier, about a week and a half ago. So it's rotating off, but I think it's still active. I think it's still throwing CMEs off that direction. Could be flaring a little bit, but remember what was odd about that, and I don't really want to, I guess not normal would be the proper word for that. It was a very active sunspot in terms of flaring, but it did not produce any CMEs until it got over here, and then it produced one that really wasn't all that big. So, yeah, I mean, you take that for what it's worth. Now, this is the 171 angstrom. This is a part of the light spectrum that we can't see with our eyes. They assign it a color, and it is a gas, a specific gas. And also, I've seen a video, guys, Suspicious Observer, Ben Davidson, he put a video out, I think it was a day or two ago. Actually, remember I told you guys I was going to go find out what gases we're looking at on these things? on the SDO imaging, on the extreme ultraviolet, and why we look at specific gases and why we want to see different things. He actually did like a 3-minute video explaining all that. I was like, wow, I just, I was getting ready, I was telling my audience that, hey, I'm getting ready to go do that for you guys, and he did that, and it's really short, concise, and to the point. So go check that one out, and you'll understand. I'm still going to do it here so we know, so I can show it to you and all that stuff. I just haven't had time to do that yet. Now, this is the 304 version. This is what we look at when we look for filaments and the plasma. We can see plasma density on this one really well. So these are some of the imaging you guys would get when we get the big ones, like on the limb, and it like shoots way out here, and it's all dramatic looking, and it's beautiful. It really is a beautiful thing. Really cool to see that kind of stuff. But as you can, I want to show you guys this here on the southern end of the sun here. I'll show it to you real quick. I just think it's interesting. This is a magnetic filament that's just kind of pushing off the south. And we probably wouldn't really even see this a whole lot if this position was here, because the sun would be camouflaging that. And I showed that to you guys yesterday. But you see how that's spinning? Okay? That's what we call a solar tornado. Okay? And that is not wind. So let me explain. That's a magnetic connection line that is in that shape. And what you're seeing, what makes your eye think it's spinning, and it kind of actually is anyway. I guess the better word would be spiral. Because you've got plasma traveling on that line. And that's what you're seeing. You're seeing the plasma travel on that magnetic line. So it's not like wind from a tornado here on our planet. So when you guys hear that, sometimes they're called solar vortexes. They're called different names sometimes, and we do see really large ones sometimes. But all that means is you got a magnetic connection line that's reaching way out. But I wanted to bring attention to that, because I'm sure you guys will start hearing that term more often. I've explained that a couple times here on my channel. So, but we also got this coronal hole. Now, this coronal hole here is not really impressive, but they don't have to be. They don't have to be, impressive to your eye here. So that's a hole in the sun's atmosphere, and the black is the surface of the sun. So when the atmosphere opens up, plasma flows out, and it gets here, it's highly charged particles, and it gets here on a magnetic connection line. So that's how that travels to us. So when this is right in front of us, now the Earth strike zone is really kind of up here, but we do tend to connect to things a little bit more southern, a little bit south of equator. So when we see things in the southern hemisphere as far as coronal holes, we will connect to those. It seems to be more often. And when that happens, we get a stronger stream. So, okay. Now, for anybody that don't know what you're looking at there, the difference is this right here is our current sun. This was back in 2020. This is solar minimum. Hey, Trinity, thank you, girl. Good to see you. Hey, Miss Dragon, good to see you. What's up, Miss V? Renee in the house. Butterfly. Bill. His real lights. What's up? Okay, so thanks again, Trinity. I appreciate you, girl. Now, again, we look at different ones for different reasons, and most people that do space weather will have their favorite view, okay? And again, this is just parts of the light spectrum we can't see with our eyes, right? So we see very little of the light spectrum. Our eyes can't see much of it. So we have to put these filters on here so we can see the specific gases and stuff to give us a better visual observation so we can understand better what's going on. That's why we do any of this, okay? So the 171, it's good to see the corona on this one. You see how it's kind of hazy? The whole imaging is. And if you scroll down, again, I've already told you this one here, the 304, dark plasma. It's easy to see the density on this. And we see the filaments really well on that. Now the flaring, like solar flares, they don't show up real well on this one a lot of the time. The purple one, the 211, this is the one I go to for showing you guys coronal holes, because it does show the holes a lot better. For instance, you see this hole here? Where's it at here? It's not there, is it? So you wouldn't even know there was a coronal hole unless you actually looked at the different part of the light spectrum here. And that's the point. That's why we do this. The 131 and the 94 are really good at looking at flares. They show up really bright, okay, on these. And that's why I'm showing it to you. Now, I will say this. The 193 or 195. GOES uses the 195. SDO will use a 193 part of the light spectrum. But they see very similar things. The 193 will show you probably the best overall view. If you just want a big overall view, only look at one image, one extreme ultraviolet part of the light spectrum here. So if you look at the 193, you're going to see coronal holes. You're going to see flares. You're going to see everything I just talked about. But they won't be as, I guess, vibrant as if you pulled them out and looked at all the individual ones. So if you want to know like a big overall, hey, this is what the sun's doing, you could go look at that one. But I choose not to do that because we get a little bit more detailed on this stuff. Okay? That's why. All right. So, let's go over here to seeds. Now, I'm going to show you a satellite called SOHO, and it's got the LASCO C2 imager on the satellite. Okay, this is what's taking the pictures, taking the imaging, and it's 1 million miles closer to the sun than what we are, and sits right here. It's always looking at the sun. Essentially, it's from our point of view. So if we look at today, we'll just take a look at it, and the image on the left is, both of these are coronagraphs, but this is the difference image on the left. And I show it to you because you got, again, you get a good contrast of black and white. And when it does fire a CME, it shows up really well on this imaging. Now, as you can tell, there's not much going on today, which is why I wasn't in such a big hurry to come out here and do anything yet. I've been kind of waiting because I did the live stream with Tommy last night, and even from that point forward, there really wasn't much for me to do to show you guys. It would have been just kind of a short little, hey, slam, bam, here we are, right? And I'm going to do that. I'm going to try to, if I hadn't done that live stream with Tommy, I would have come on and gave you guys a short update anyway. But like I said before, guys, I will take a day off probably through the week. Sometimes. It's not going to be every week. And most likely one day off on the weekend. Unless if something big is happening, I promise you I will be here. There's no question about that. Even if it's just me popping on saying, hey, this big thing just happened. You're going to get that anytime that it happens. Okay? I watch this stuff constantly. That's just what I do. So, anyway, you see these eruptions. And some of this was back on the 28th. And I think, if I'm correct here, that blast there, and then they got that one there. So I think this one up here and this one down here could be like the one that they think is going to be impacting maybe a possible glancing blow. I tell you what we could do. I should have done this already. Wasn't even thinking about that. Because Dr. Tony Phillips is reporting on it too, right? They say a CME might be grazing Earth's magnetic field late on March 2nd. Now, if you guys come over here and you look at this, he always puts hyperlinks in his articles, right? You can click on that. It's going to show you the CME. Well, see, he's showing you the same day. So most likely it's that one or even that one maybe. I don't know. It's hard to tell because they are blowing off the sun at once. And hey, Scuba Steve, thank you, bud. Appreciate you. Thanks, guys, for the support. I really do appreciate it. So yeah, I mean, you got that going on there. And like I said, guys, when we're talking about solar maximum, this is what I'm talking about. It gets a little difficult to forecast it because so many things are happening at once. All right, so, and I wanted to show you this also. I'm going to go to the Discover data. Hold on a minute. Grab this real quick. I think it's here. Okay, yeah. So, I got you over here at Discover, and this is our space weather data, and that's what we look at. And I'm not going to bore you with the graph. I'm trying not to show you these kinds of graphs all the time because I know it's kind of boring. So I'm going to get straight to the point. You guys see this right here? How it's a big jump in density. Okay? That's not a true reading here. That's a false reading. And let me show you why. See how you got 54 on the orange there? Again, that's density. Now if you go down here, you see it again, right? Another jump like that. I can't remember what density that went up to, but it went like really high also. 44. Okay? Notice how everything moved just a little bit. The temperature, the speed, the density. The only thing that didn't get affected was the BZ, which is our magnetic polarity of our magnetic field. Okay? And we look for -6 on that to see if anything. That means we're in a proper position to let things really just kind of come into our system and give us a good shot from a CME. Okay? This here is the phi angle. That's the actual polarity of the solar wind itself. Now, we're always getting hit with solar wind. Okay? Constantly. It's just sometimes we get the surge from the coronal holes and CMEs. Okay? So, but this is just the ambient solar wind, and this is the polarity of it. Remember, I said it gets here on a magnetic connection line. Why does magnetics matter? Well, you got a positive and negative, so positive and negative will draw things to one another. So that's how these things travel. Okay, so the polarity of the phi angle or solar wind here is really what we're looking at. Matters. Okay, so when that flips, like right here, a lot of times when that happens, we'll get a little jerk on our magnetic field, and it can actually put you into a short-term geomagnetic storm just by doing that. So if this kind of a scenario here, if that happens at the same time we get hit with the CME, you know, it could intensify the CME. So that's one of the reasons why we look at this. But again, this right here, guys, is a false reading. These little spikes right here, and I'm going to show you why. You see this? These time frames line up on both of these graphs. This is showing you X-ray, right? So if I go back to the Discover data, this is not showing you X-ray. This is showing you density, speed. This is showing you space weather conditions. Okay? But these time frames line up. This crazy little jump here and crazy little jump here line up exactly with this. What's that mean? Well, this is a data dropout. We can't get the information from the satellite, okay, or it can't collect it. So when that happens, the models sometimes don't know what to do. And it's a flaw that I think they're still working on the models. I'm sure that they are. But it ain't going to matter if you can't get the data or you can't receive the data. You're not going to know what's going on, right? So I'm not sure how you fix that on a model, but it's way above my pay grade, I promise you. But I wanted to point that out because this is entirely normal. If I was to sit here and tell you that this is a real reading, that would mean that there would be no X-ray at all. Okay? And the only way that that happens is our sun would have to go away. Okay? I mean, that's the only way that that happens. So, just saying. And it still might not happen because there's other sources in space sending x-rays everywhere. So, I don't know. That's just a false reading at the end of the day. So, all right. So, as these CMEs glancing below might be hitting us, I'll be keeping my eye on this. This is our magnetosphere. And this is velocity. Sun's off to the left. And it's our magnetic field, basically. Just to kind of give you a basic, hey, this is just a basic thing here. There's the bow shock. Okay, and this is just showing you speed and speed only. Notice how things behind our bow shock are different than in the front. That's because it's being protected by our magnetic field. Things are slower in here. If you see this, the darker oranges and reds are faster wind, and the stuff in the middle is really slow. So inside our protection, it gets slower, which is good for Earth. Okay, Earth and our satellites. So, and I know it kind of looks like it's moving around there. It kind of is, but it's nothing to worry about right now, I would say. Now, this is density. Okay. The light colors are lighter density. The darker colors are the darker ones. Now, remember, we're looking at density only. This isn't showing you speed or anything else. This is just showing you density. So, we hear this a lot. People will say the bow shock is down. And I've even said that before myself, not understanding what this model is actually showing you. Okay? If you keep in mind what I just said, this is only showing you density. So, if the density is the same on this side of the bow shock as it is on this side of the bow shock, you're not going to see the bow shock because it's all going to be blue, one color right there. It doesn't mean it's gone. Okay? If our bow shock ain't there, that means our magnetic field is not there. That's what that means, guys. Or the sun isn't there. Both of those scenarios is a real bad day for us here on Earth. Okay? Just saying. Just saying. Now, and there's nothing like extravagant going on right now. I'm showing you guys these so you know what I'm looking at when I'm talking about geomagnetic storming. These are the things that I look at to come to you guys and say, hey, we may have a geomagnetic storm. How do I know when it happens? I come look at this stuff. Okay? And I show it to you guys because you guys are smart and you guys can understand this. You don't need me to tell you what to think and how to think. You know what I mean? So I want to show you guys how to go look at this info for yourself. And this is what I'm doing right here. You don't have to have a complete understanding of everything to have a basic understanding of everything. Okay? So this is magnetic pressure. Okay, you can see how we got some what is termed backside pressure. It does not mean that we're getting blasted from the back. That's not what that means at all. Okay, most of the time when we're getting pressure here in the back, we're getting a lot of reconnections. Okay, so if the stuff is hitting from left to right from the sun, we're deflecting it, well then it reconnects because the magnetic fields get kind of disrupted. And when it reconnects, it actually will come from behind. Like that. It's easy to see at certain times. And when I do see it again, I'll show it to you guys again. Actually, if I go up here to the speed, I can probably pretty much show it to you now. You see these blue? That part of the solar wind is moving at the same speed as this dark part. Okay, so if you see this graph up here, this says negative and this says positive. We're looking at magnetics here again. Okay, so why do we do that? Well, it shows you direction. So the darker reds are moving from left to right. Okay, and so oftentimes when we see the blues, they're moving from right to left because it's opposite polarity. So when we get the reconnections from the backside, you might see it here. Let's see if we can see one. You see how that's red right there? Let's see what happens on this one. I haven't looked. Yep, you see that? Look what's happening. See it got broke? See that magnetic line got broke right there? And now watch what comes in from right after that. Here comes the blue. Reconnect. Another one right here. Watch. Reconnect. You guys see how that's happening? That doesn't mean that anything's sitting right here, okay? That's not what that means. Now, we do get space weather from behind, okay? Cosmic rays and stuff like that. But that's not what we're looking at here. Okay, so that's a very, very visual way to show you guys that reconnection. So I can show you when that line gets pushed this direction, and then it reconnects. So that's what's happening there. All right? Butterfly, what's up? Anna, Jerry, Renee. So, Aurora. Now, I do want to talk about this for a second, only because Dr. Tony Phillips was. I'm giving him credit for that, for sure. I wasn't even going to speak about this till I saw this. So, thank you, Dr. Tony Phillips. Appreciate you. I knew this already, but I wasn't going to report on it. We do see more geomagnetic activity around the equinoxes. Okay? Spring and fall, right? So March, the Aurora numbers go up because of that. March and April. You can see right here. He's showing it to you here on the graph. And then in the fall, you'll see the same thing. Okay? All that means is those are our peak times of geomagnetic activity. We get a lot of really big, like 2017, September, we had a huge solar storm, okay? Yeah, it was a big one. So that stuff falls into that, right? Let's see here. And remember, those are equinoxes, and it does have stuff, it does have everything to do with the position of our planet and all that kind of thing. I'm not going to get into that right now, but please go check this out over here, Dr. Tony at spaceweather.com. Give him some love over here on his webpage, please. Now, what you're looking at here, this is ice halos. Okay, we see these a lot, and especially this time of year, in whatever hemisphere we're talking about. But these usually happen closer to the poles, and it's ice crystals in our atmosphere, and then obviously light's bouncing off of it, creating these kinds of effects. Okay, so yeah, he talks about that there too. So please go over here and give him some love, guys. So anyway, the Aurora is going to be kicking up if we get hit with a geomagnetic storm. Here's a model I show you guys quite often, but probably not often enough. Okay, so what you're looking at on the left is the northern hemisphere, and on the right you got the southern hemisphere. Us northerners, I guess you could say, people that live in the northern hemisphere, we only hear the word northern lights, right? So it kind of lends itself to think, well, maybe there isn't southern lights, right? Well, there absolutely is. Okay, so it happens around the poles. Why? Because like I've said 1,000 times, stuff comes in easier on our poles. So when those highly charged particles hit our poles like that, it excites some of the molecules. And however hard the hit is, if it gets in deeper, it will excite different types of molecules, particles, right? So you got oxygen, you got nitrogen, and a whole lot of other things. Oxygen typically will show up as green. Nitrogen, when it gets excited and shows you aurora, it will be showing you like a reddish color most of the time. Okay? So, and what we see is when those particles get excited, what produces the color is the process of them going back to their stable state. You don't see it when it like gets excited real quick. You see it going back to its more stable state. Okay? So that's what's happening. That's what, technically, that's what's causing the color to show up. All right? So I've explained that before, but and I'm not going to go into too many more details. But Ilea, most of you guys know her. She's her and Trinity and Rip and everybody else here, all the mods and stuff. Ilea watches the Aurora quite often, and there's sites where you can actually go see live. I've shown them to you guys before. Live feeds. They're just cameras set up and they're watching Aurora. It's a beautiful thing. It's relaxing, I can tell you that. Okay, so if you guys got any questions, let me know. I'll try to answer them real quick. But guys, here is the lifeboat. Guys, he is so close to 20,000. If you guys could please just do me a favor. Here is the live stream. If you want to know what Wages World looks like, I show my face over there. Okay. Go over here to the lifeboat. One of my mods, that'd be great if you guys could drop that link. It would be awesome if you could do that for me. But that's this right here. This is the show I was on. It's got you guys see it. It says Wages World back at home on the boat. And that's exactly how I felt. It's home for me, guys. I co-hosted with Tommy for almost 2 years over there. I mean, he did most of the talking and stuff. And I was the one, as was deemed, behind the glass. And that's a cool term, by the way. I ran a lot of the technical stuff behind it. Now his son does it, and his son is doing a killer job of it. Okay, just so you know, they're doing really well. Okay, and I'm proud of all of them over there. And I guess I can include myself in that because I still feel like I'm a part of everybody over there. Tommy and Johnny and everybody over there, they're my brothers anyway. So, but please, guys, do me a favor. Go over there and subscribe if you're not. It would be great. It really would. I want to see this click to 20 is what I want to see. You know, so much work is put out over here, and it's right now they're at a pepper show, and they're meeting and greeting, and anybody in New Mexico wanting to go meet and greet down there, they can do that. They're there. So, thank you, Trinity. Appreciate you. Awesome. So there's the link, guys. So please click on it. Say, hey, Captain Wages sent me. Say that. Put that in the comment section. Be awesome, guys. You're doing me a really, really solid if you guys go do that. So, but yeah. So a little bit of a recap. We are expecting maybe possibly a glancing blow. We could get into geomagnetic storming. We have a big sunspot getting ready to face us. It's rotating in right now. This one here. Okay. If it continues to be active, we could see more geomagnetic storming in the future here in the next few days, this weekend. We have this coronal hole. Now, it's small, but it doesn't mean it ain't going to increase our geomagnetic activity. Because if we connect to that, it will. So, and remember, the auroras, they spike in the spring and fall. And so does geomagnetic activity. So we're watching out for more eruptions, guys. This is, the spring and fall is the most active time on the sun. Okay? That's why. So, but that's all I got for you guys. Thanks for coming by, swinging by. But please go over there and subscribe over there. Come check me out over there, guys. And we'll see you there. I'll be back tomorrow, guys, to give you an update. If there's nothing going on tomorrow, I'm going to try to wait to see if that CME hits. Okay? But please turn your notifications on. That way you also get notified when I post a community post. There was one day I couldn't do a stream and I had to post it in my community post. Some people probably didn't see it. So that's the only reason why. You'll get notifications. Click the notification all also. Okay? That way you get all the notifications. But anyway, guys, God bless. Thanks to all my moderators, Renee, Rebecca, good to see everybody. Trinity, Miss V, you guys are awesome. Hey, Terry, what's going on, bud? You guys want to see some good earthquake stuff? Go check out Terry's channel. Good stuff he reports on. Let's see here. All right, guys. Anyway, guys, God bless. Yahusha saves, and You can drink this Kool-Aid.